Good morning, good afternoon, good evening, depending on the time you come across this video. Welcome to my channel. Today's video is going to be on how to size solar energy. First of all, we start with the electrical load sizing. That's the electrical load usage per day sizing. So after that, you prepare a table. This is the first step. You prepare this table. We start by the load, the power, the quantity, the hours, the watt hour, and the total power. When you're done preparing the table, you input whatever thing that will be used with the solar system. First, we start here with our fan, and the fan is going to be 80 watts. The quantity of the fan is going to be 3, and the fan is going to be on for 4 hours. For us to have watt hour, we multiply this 80 times 3 times 4, and then we have this. For us to have our total power for the fan, we have to multiply 80 by the total number of the fan that will be used in this system. That's why we have this 240 watts. The same thing goes with the lighting point. Each of the lights is going to be 10 watts, and we have a total 5 pieces of lighting point, and also going to be on for 4 hours. So the same thing, for us to have the watt hour, we multiply 10 by 5, and then by 4 we have 200. The same thing to the power, total power of the light, we multiply 10 by 5, we have 50. The same thing goes to the television. The quantity is 1, and it's going to be on for like 2 hours. If you multiply this by 1 by 2, you have this. If you multiply this by 1, you have 100 watts. Same thing go to our audio box, 60 watts, and we are going to have a total of 3 pieces, and it's going to be on for like 3 hours. You multiply 60 by 3 hours, and then you have this. You multiply this 60 by the 3 quantity, you have 180. After we are done with that, we sum the watt hour and the total power. We sum them, so we call sum total. We have this to be 1900 watt hour, and this I want to be 570 watt hour. The second step, sorry, I made a mistake. After we are done with this table, the next thing you need to look at is the inverter, not the battery. I made a mistake, that's why I cancelled it, and then start with the inverter. Okay, after that we enter inverter sizing. For inverter sizing, we say that we need total electrical load, which is this total power, which is this 570, and then we say inverter size is equal to total electrical load times correction factor divided by efficiency. That's inverter efficiency. So our correctional factor is equal to 1.2, and inverter efficiency is equal to 80%, which is equal to 0.8. So by so doing, and then our inverter size is going to be equal to, bracket open, 570 watt times 1.2, bracket close, divided by 0.8, which is going to give us 855 watts. So therefore, our inverter size now is equal to 855 watts, and then we're going to round it up to be 1000 watts. Since we cannot find this 855 watts in our local market, what we have is 1000 watts or 1.5, which is 1500 watts or 2000 watts or 3000 watts thereabout. So right now we are going to choose 1000 watts because it's even above this 850 watts. So after that, we go for our battery. So the next thing is that our step 3 is going to be battery sizing. Remember, when we were doing our calculation here in the table, this table is very important. First, you need to start with your table if you want to size your solar system. For those who normally install inverter, this is how you go about it. So you see, in our watt hour, we have it to be 1900 watt hour. So after that, from that we are going to use to size our battery. So here in battery sizing, we have battery capacity to be equal to watt hour, and then our watt hour there in our table was 1900 watt hour. So we now say, okay, what is our battery voltage? Our battery voltage is equal to inverter DC input voltage. We all know that 1000 watt inverter do operate with 12 volt battery voltage. So that's why we have this 12 volt. And then we now say, okay, our battery current. What will be our battery current? We now say our battery current is going to be watt hour divided by battery voltage. That is watt hour divided by battery voltage. So we now have 1900 watt hour divided by 12 volt. So with that, we have this to be, with this now, it's equal to 158.3 amp hour. So since we don't really have this in our local market, what we have, the nearest thing we have is 200 amp hour. So we are going to run it up to be 200 amp hour. So after that, we now said, so therefore recommended battery capacity is going to be 200 amp hour times 12 volts, which is equal to 2400 watt hour. With this is the recommended battery for this setup. So now after that we are done with the battery, we now move forward to solar panel sizing. Sorry, I didn't put IG. Okay, so in our solar panel sizing, these are the things you need to look at. First, we need to know that we don't have a stable weather condition, which means that our weather condition do varies. We have summer, we have winter, we have the one called monsoon. So by so doing, our solar, for us to set our solar panel, we start by looking for the average sun hour, which is equal to summer plus winter plus monsoon divided by 3, because they are all 3. So after that, we now define our winter, and our daily, the daily sun hour in winter is minimum is 6 hours. The daily sun hour, the daily sun hour in summer is 6 hours. For winter is 4.5. For monsoon is 4. And then we say average sun hour is equal to 6. Remember the formula: 6 plus 4.5 plus 4 divided by 3, which gives us this. So required solar panel size is equal to recommended battery capacity, which is this 2400 watt hour, divided by average sun hour. That is bracket open and then bracket close, and then divided by efficiency. You know, the solar panel is going to have efficiency, and the efficiency is always 80%. So by so doing, we now come here and say solar panel size is equal to 2400 watt hour divided by 4.83 watts. 83 hours, sorry. Hour cancel hours, and then divided by 0.8. The 0.8 is the 80% efficiency, and then we now have this to be our watts, recommended watt. Our watt. That is our solar panel watt is 621.1. We run it up to the nearest value. We have it to be 621 watts. So since in the market or in the solar system store, we don't have this, instead we rather have 660 watts. So therefore we now say our recommended solar panel is 660 watts. So the next step is going to be number of the solar equipment, which is what make up this equipment: the inverter, battery, and the panels. So now we say inverter is equal to 1000. This is the recommended power, and then this is the minimum size that is available that can go with this. So we now say 1000 divided by 1000, because 1000 is the minimum size that can go with this. You understand? Although we have 500 watts. Why 500 watt cannot go with this? 500 watt is under this, understand, under the recommended power. So now say 1000 divided by 1000 give us 1. The same thing go to the battery. Remember our battery was 2400 watt hour, the capacity of our battery. Now say 2400 watt hour divided by 2400 watt hour. This one is available, although we can still go for something under, but it's recommended to use the exact. So when this goes to this is equal to 1. In our solar panel, we now say recommended panel, which is 660 watts, divided by 330. Since we have 330 in the solar store, we can now use 330 to divide. But if we should, for example, if we should not, or if we should decide to use 660 watts, we can still use it. That way we can only use this one alone. But since we have 330 watts, we now say 660 watts divided by 330 is equal to 2. So therefore we now say our inverter is 1 pieces, battery 1 pieces, solar panel is going to be 2 pieces. That is 2 of 300 watts. 330 watts. So by this now, I hope you can be able to size your solar system for your installation. This is just for example purpose. If you want to do that, you first of all start with the table, because I've seen a lot of people making mistake in their installation. I've seen a lot of mistake on the media. I've seen so much, so I decided to create time for me to make this video. So in my next video, I'm going to discuss on how to size the cables. Because I also see so many errors. People undersize their cable. They use undersized cable to run their installation, which is very bad. It can cause fire outbreak. So with this, I hope you can be able to size your system and do a proper installation. Thank you for watching my video. Don't forget to subscribe, don't forget to like, and don't forget to comment if you have anything to comment. Also, don't forget to follow wherever platform you see this my video. You have to follow, subscribe, and don't forget to share with your friends. Bye.